Sorry, I'm late 10 minutes. Okay, give me a second. Okay, thank you. Okay, okay, this is our fourth lesson. You already know, we already discussed our basic lessons, basic parts of the syllabus. First, we discussed basic measuring instruments that we used in physical quantity measurements. Then we discuss our basic physics lesson, the force lesson. Yes, force lesson. Then last week we completed our lesson number 1, area and volume. Then this is our fourth lesson. Actually, it is not the fourth. I think it is the lesson number is 7th, as I remember. Don't need lesson number. It is in our fourth lesson. It is actually same as the second part of the force lesson. It is same as second part of the force lesson. Therefore, the force lesson basic knowledge you need for this lesson, and otherwise in the area and volume basic concept like radian measurements, radian and degree relationships, and radian to degree conversion, degree to radian conversion you need for this lesson. This is the first advanced lesson, because in our measurement lesson we already discussed what are physical quantities. You have in O-level time, before that you already have some basic knowledge about physical quantities like length, weight, mass, time. Like measurements, you have few idea. Then we only discuss measuring instruments and how we use this measuring instrument and what are the errors regarding each and every instruments. And also in the force lesson we discussed very basic things: Newton's law, the force dissolution, that we already know in the O-level time, but additionally discussed little bit in the lesson in our syllabus in A-level. But it's also not very new for you. You already know the things. But in last week completed lesson, area and volume, everything you know, I think, before that. Only you want to revise that and practice few advanced questions. Okay, this is the lesson. From today, we're going to start very new lessons. Now you never learned before. So then the continuous attending and continuous work consistency in this lesson is very important, because if you miss any part, this rotational motion, again you can't understand. That's the thing. Okay, I think you all have tubes. Okay, this is the rotational motion tube. This is a rotational motion. It is very small lesson. But if you go through the tube, you can find lot of new equations, right? Force lesson, if we discuss the equation in force lesson, but they you already know the F equal ma and acceleration equations and basic equation that you already know in the O-level time. But it is a lesson you have a lot of new equations. See, you have a lot of new equations, but that's why I told the continuous attending is very important. Otherwise you can't understand this. Actually don't worry about these equations, because if you got full idea about this concept, if you got the full idea I mean if you got the uh, conceptual idea of each part, full idea, then even without calculation, if you not remember the equation, you can do this calculation and get the answer, no problem. Okay, therefore continuous and consistency is very important. Consistency is very important after this lesson, not only this lesson, after that every lessons. Now up to now we discussed our basic things. Group number 2 students, we have first lesson within this month. I think within this month we can't. Within next month, before next complete next month we can complete. Now we discussed about up to course resolution we did last week. Then yes, we can discuss the, we can complete the first lesson within next month. Okay, then the force completed, measurement completed, area volume completed. This is our fourth lesson. Okay. Okay, the tutorial of this rotational motion lesson I have given in the page number 10, final page. This is a tutorial. If you can improve up to do these questions, that enough for rotational motion. Okay. Okay. The other thing, your next exam, next exam, will be held, exam number 2. The date I have already scheduled, right? I have already scheduled. What's the date of the exam? Wait. Final Saturday, yes, 25th of November, no, October. Remember, 25th of October, you have 2 weeks, you can ready. 25th of October, Saturday morning. Saturday 8:30. 8:30 to 10:30. It is a 2-hour paper. It's a 2-hour paper. I will say it is not only MCQ. It's not only MCQ. You have MCQ. You have 20 MCQ question and you have one structured essay question. One essay question. One essay questions. This is a paper structure. Yeah, that's only. 20 MCQ, one structured essay and one essay question. For 20 MCQ, you have 1 hour. 1 hour. For structured essay, you have 30 minutes. For essay part, you have 30 minutes. Okay, that's altogether 2-hour paper in the final week of this month. It is compulsory for both groups, 1 and 2, all students. Group number 2, first exam, we can complete after complete the post lesson. Don't worry about first exam. Come to exam number 2. Okay, any doubt? Then I'm going to, in doubt about any previous lesson or exam? Okay, then I'm going to start our rotational and circular motion. Rotational and circular motion. Rotational and circular motion. Rotational and circular motion. Okay, don't think about this rotational and circular motion. How many motion types do you know up to now? in engineering technology, I think in automobile parts, you're doing a lot of motion types. Okay, if you think the vehicle motion, the vehicle is moving on a straight road. Think it is highway. Then what is this motion? This is a vehicle. Vehicle. It is moving along a straight road. Moving along a straight road. What is this motion type? Think it is moving like this. The board is clear, right? Clear neither. I think no problem. Kabir? Yes, very good. Kabir, is it clear? Okay, thank you. Is the linear motion? Yes, it is the straight line, the motion like straight line that we called as linear motions. Yes, linear motion is a one type. Linear motion. Okay, what else? Other motion types? What else? What else? You know, in the piston, in the engine, the piston, you know, this is a cylinder. The piston, how about the motion of piston? It is up and down motion, like up and down motion. How we call this? What's the name? Reciprocal motion. Very good. Reciprocal motion. Up and down motion. Reciprocating motion. Reciprocation motion. Okay. Okay, they are the different motion types. Samely, if any object rotating like this, object rotating as I in our background like this, if any object rotating, yeah, no signal, object rotating, then it is mainly two rotational types that we called as rotational motion and circular motion. Rotational motions, mainly two types. Rotational motions mean rotating motions in object rotating. Mainly two motion types. It is rotational motion and circular motion. Okay, first of all, you need to understand what is the difference between this rotational motion and circular motion. What is the difference between this rotational and circular motion? What's the difference between this rotational and circular motion? Okay. Do you have any idea? What's the meaning of the rotational motion? What's the meaning of the circular motion? Okay. Before that, where is our this one, the earth rotation. The earth rotation is a rotational motion or circular motion? What do you think? This is rotational motion or circular motion? No, send me your own idea, then we can discuss today. What do you think? It is rotating or circulating? Yes, it is rotation. It is rotation. Yes, it is rotation. Yes, I think now you have basic idea. Okay, now let's move into our definitions Okay, the rotational motion mean, that's the meaning. Okay, think the rotational plate. It is a rotational plate. Think it is a metal rotational plate. This is the rotational axis. When this plate is rotating like this, this is a plate. Then it is rotating in this around this axis. Okay, that we called as rotational motion. Why? The rotational axis within the object. That's the point. That is the rotational axis. That's the rotational axis. Rotational axis. Rotational axis within the object. Rotational object. The rotation, if the rotational axis within the object, that we call as rotational motions. Rotating objects with rotational axis within the object. Okay, that's the meaning of the rotational motion. Okay, can you send me what are the examples for rotational motion? Rotational axis within the objects. That's the point. The rotational axis within the object. Object rotating, the rotational axis within the object. Okay, what are the examples? Send me your experience. Okay, I can send you, I can suggest one example. The example, the wind turbines. Wind turbines mean all types of fans. Yes, fans and turbines are rotational motion. Fans and turbines. Okay, what's your ideas? What else? Sadev? Yes, vehicle wheel, very good. Vehicle wheel is rotational motion. Vehicle wheel. Vehicle wheel. What else? Yes, steering wheel. Steering wheel. Yeah, ceiling fans. Yes, steering wheel. Steering wheel. What else? Yeah, turbines. Turbines also type of fan. Yeah, DVD. Very good. DVD. DVD. Or any drive. It's rotating. Yeah, merry-go-rounds. Merry-go-rounds. Okay, merry-go-round. If we think full merry-go-round, it is rotational motion. But if you think, Kabir, if you think one person rotating in the merry-go-round, it is circular motion. In the circular motion part, I will explain. Yeah, crankshaft, very good. Crankshaft. 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 Yes, earth. Earth, very good. Earth. Earth. Turbines, DVD, CDs. Okay, very good. Enough. Okay, that's the meaning of the rotational motion. The rotational motion mean when any object rotate, if the rotational axis within the object, that we called as rotational objects, rotational motions. Rotational motions. Okay, again come. Football. Football mean rotate, you know. Yeah, the dynamo also good. Dumla, I think so. I don't think so. The football, is it rotating? I don't know. That's when goal එකක් ගහද්දි. Yeah, it's also, but it is moving. Okay, now after discuss circular motions, you can understand the difference. Okay, Come to circular motion. Circular motion. The circular motion is simple. The circular motion means, think example, think this is a string, and this is a whatever object, think it is a stone, Calcutta, stone. Okay, when it is rotating this axis, the stone part, this object rotating in the circular motion. Then what is the definition? When any object rotating, the rotational axis outside from the object, this type motion we called as circular motion. Okay, this is the rotational motion, sorry, the rotational axis. This is the axis now. This is the axis. It is outside from the object. This is the object. Rotational axis outside from the object. This is the axis, this is the object. Then the object is rotate in the circular path. This type rotations we called as circular motion. Circular motion, the object rotating around any axis. That's the meaning. Around axis, that means the rotational axis outside from the object. This is the rotational axis, this is the object. It is outside. Outside. Okay, now send me examples for circular motion. Yes, in Kabir example, the one person in the merry-go-round, then it is circular motion, right? If any, consider about any seat, like a seat circular motion. Then you can get one example, one seat or one person in the merry-go-round. Okay, what else? Yeah, fan blades. Yes, fan blade. What else? Yes, it around the sun. Very good. I have given example. No, if any object rotate by a string, moon when orbit around sun. Moon is around Earth, right? Yes, clock hands. Yes, they all are circular motion object. Yeah, Earth rotate orbit around this. Yeah, that is circular motion. Okay, that between what is the difference in rotational motion? The rotational axis within the object. In circular motion, the rotational axis outside from the object. It is circulating. Circulating. It is rotating. Understand the difference? Rotating and circulating. Okay. Now go to the tute. I have given clearly in the tute. I can't remember that. It is our 8th lesson. Okay. Get the tute. I think you all have tutes. You all have this tute. Okay, the rotational motion is, I have given the particle of matter, a solid object or a system more around an axis. That's a form of motion called rotation. In the axis of the rotation of rotating objects lies within that object. That we call, this is a point. Within this object. It is within the object. Within the same object. Then I have given, this is earth rotation and wind turbines. Wind turbines. Okay, what is this? What's the name of this equipment? What is this? Do you know this? Spinning top. Yes. No, no, no. It's not a spinning top. No, it is a equipment. It is a equipment. Yeah, we can take the shape as top. The top also, spinning top also rotational motion. But this is a centrifugator. 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 It is a industrial equipment that we use for centrifugate. Centrifugate any liquid or think in industrial chemistry we can again discuss about this centrifugator. The centrifugator is an instrument centrifuge and we can separate density different liquids. Density different substance we can easily separate. As example, in industrial chemistry, we discussed the soap production. In soap production, the final product, still you don't know, the final product, it is producing soaps and lot of byproducts. Byproducts. The main byproduct we called as glycerine. Glycerine we soap sitama hadin. Then the soap and glycerine, it is two density liquid, two density substance. By this centrifugator, we can centrifuge this. Centrifuge mean rotating, like this, rotating. While rotating, high density particles mean glycerine. High density particles we can separate as lower density, and low density particles mean soaps. Then we can separate soap. Okay, that's for extra knowledge. Okay, that's the centrifugator also rotational motion object. Rotational motion object. Okay, if you want, you can write down more examples that we discussed in the vehicle wheel, steering wheel. You can note down in the tute. Okay, if you want, please note down this. The fan already given here. Vehicle wheel, steering wheel, DVD, CD, crankshaft, earth. Earth is given, right? Okay. Quickly note down examples. Okay. Then move into our circular motion. An object is rotated so that the axis of rotation is outside from the object. Outside from the object. This motion is called as circular motion. Okay, this is satellite. Satellite rotates around the Earth. It's also a circular motion, right? This is a stone rotating by a string. Stone rotating by string, like for whatever particle, right? Then you can write more examples. Person on merry-go-round. Okay, you can complete. Okay. Okay. Now you have full idea What's the meaning of the rotational motion? What's the meaning of the circular motion? What is the difference between rotational and circular motion? Okay, now I'm going to compare up to O level. I think grade 10 first lesson. What's the name? Science grade 10 first lesson. What's the name? Do you remember? Grade 10 lesson number 1. Do you remember the name? Nam matakayද? Motions, right? Motions කියලා නැති. Motions. So මතකයිද අර මෙහෙම velocity time මෙහෙම graph තිබ්බේ? Yes, in the grade 10 first or second lesson, I can't remember, first or second lesson, you discussed what are the physical quantities you can use for linear motions. Okay, what are the physical quantities you can use to measure linear quantities, linear motion quantities? Linear motion quantities. Linear motion quantity. Okay, semi linear motion physical quantities, vector and scale both. Yeah, the first is distance. Do you remember? The distance is the first physical quantity that we can use to measure the linear motion. Yes, matakaide? The distance. Okay, what's the meaning of the distance? What's the meaning of the distance? Distance, what's the meaning? Distance. Sandeep, how we can define the distance? Okay, if not, the distance is vector or scale. Distance is vector or scale. Is it vector or scale? Vector or scale? Yes. Good, Fatima. Yes, all are correct. It is a vector. It's a scale, right? It's a scale. It's a scale because it don't have specific direction. It has only magnitude. Therefore, the distance is a scale. I think you can remember if you think A and B is a 2 point, A and B, they are the distance. It don't have specific direction. On this point, the direction, this point, this direction. This point, again, this direction. Don't have specific direction. That's why the distance is a scale quantity. The distance is a scale quantity. Okay, our second physical quantity that we can use for linear motion, it is displacement. Okay, what's the meaning of the displacement? Quickly, the definition. The displacement. Very good. The shortest distance, the distance moved in a specific direction. No, Fatima. Yeah, you're correct. But the correct definition, the shortest distance between any 2 points. Right? The shortest distance, like this. The shortest distance between any 2 points. Yes, that we called as displacement. Remember, the symbol is S. Distance symbol is D. distance symbol simple D, displacement symbol capital S. The displacement symbol capital S, capital S, capital S. Okay, the second one, no, third one, velocity, 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 the capital V. Okay, what's the meaning of the velocity? Before that, displacement vector scale. Displacement, is it vector or scale? Yes, it is a vector. It's a vector. Why? It has a specific direction, like it has a specific direction. It is A to B, right? A to B, A to B. It has a specific direction, or B to A. Okay, therefore the displacement is a vector. The displacement is a vector. The displacement is a vector. Okay, now I need to get the velocity. What's the meaning of the velocity? Velocity. Very good. The rate of change, displacement. The rate of change, displacement. The rate of change, the displacement we called as a velocity. Then we can understand these basic things. I think you can, you have idea. Velocity equal the rate of change displacement. That means the displacement change within unit time. I think you already know these things. If you don't know anything, please note down, because this is not our today lesson. Okay, I only revise for you on easy understanding next part. Our today lesson is a very new part. It is never you learned before. Okay, that is very new part. We're going to discuss the physical quantities in rotational and circular motion. It is linear motion that you already know in O level, and in I think you grade 7 to 8 time you learning about them. Okay, the velocity. What's the meaning of the velocity? The rate of change, the displacement, or displacement change within unit time. The displacement change unit time mean the displacement. If you got displacement divide by, this is the velocity, then velocity equal S over T. Always unit time mean it is dividing by time. Remember, unit time, the displacement change within unit time. Unit time it is divide by time. Then if anyone divide, the time become 1. Time become 1. Like 1 second. Within 1 second, how many displacement? Within 1 second, how many displacement? Then what is a unit? What's the unit of velocity? V unit velocity unit. Yes, the displacement unit meter, time unit seconds, ms minus 1. ms minus 1 is the unit. Meters per second. Meters per second. Meters per second. Meters per second. Okay, that's about. Then velocity, is it vector or scale? Yes, velocity also vector. Velocity also vector, because displacement vector, then displacement divided by time. The velocity also vector. Okay, up to now, any doubt? Up to now, any doubt? Okay, the final one, the physical quantity used in linear motion, it is acceleration. Acceleration. Acceleration and deceleration both. What's the meaning of the acceleration? The definition? The definition of the acceleration? What's the definition of the acceleration? Yes, very good. The rate of change of velocity. Yes, the rate of change of velocity. I'm going to get here. The rate of change of velocity. Then acceleration equal velocity change divide by time, right? Then velocity change divide by unit time. The velocity change within unit time. Remember, the velocity change within unit time, that is the acceleration. The velocity change within unit time. In symbols, the acceleration is simple a, remember. The acceleration is simple a. I'll explain now again. Understand what's the meaning of the acceleration? The acceleration is the velocity change within unit time. The velocity change within unit time. The velocity change means delta v. Delta v. The delta mean change. Remember, the delta mean the triangle mark. The meaning change. Velocity change divide by time. Time in t. Okay, it is equal to acceleration simple. The velocity change divide by time, the velocity change within unit time, that's why divide by time, then the time become 1 unit. Okay, now what's the unit of acceleration? What's the unit of acceleration? If anyone any point forgot now, please note down. Okay, please note down. What's the unit of acceleration? Yes, it is ms minus 2, ms minus 1 divided by second. It is again ms minus 2. It is very basic grade 10 lesson. Okay, it is grade 10 lesson about linear motion. If you have any doubt, please ask. Anything you cannot get, can't understand, any doubt, please ask. Okay, now I'm going to erase this whole equation. Then if anything you need, take a screenshot to note down. Okay, Okay. Now you already know what are the linear scale physical quantities. Okay, now I am going to get all vector quantities in linear motion. Okay, what are the vector quantities? The first one is a vector quantity. It is displacement. 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 The first vector quantity. The second one, the displacement, the symbols S. The displacement symbol S. The second one, velocity. Velocity. The velocity symbol V. Third one, acceleration. Acceleration. Acceleration symbol simple A, not capital A. Capital A mean area. Simple A. And in linear motion, always we need time. Time. Time means simple T. The time also quantity. The displacement divide time is the velocity. Therefore, time also physical quantity in linear motion. Okay. Now, I'm going to move into our, that is rotational and circular motion. Rotational and circular motion. Rotational and circular motion. Rotational and circular motion. Okay, now in linear motions, okay, we have enough physical quantities to measure linear motion, the displacement, velocity, acceleration, time. There are different physical quantities we have. Then we can get lot of, we can explain the motion types using these physical quantities. How about the motion types? Is it acceleration or decelerating? How about velocity, uniform velocity or velocity increasing? How about the velocity change? How about the object displacement, the shortest distance, the moving distance? Okay, there are different types of physical quantities we can use for the linear motion. Oh, we're going to discuss what are the physical quantities that we can use in rotational motion. Rotational and circular motion මොනවද use කරන්න පුළුවන් physical quantities. Okay, the first one, the displacement. The first one, displacement. Displacement. Okay, what's the meaning of the displacement? The shortest distance between any 2 points. In rotational motion, now imagine a fan motion. Fan එකක් rotate වෙද්දී, while rotating a fan, is it possible to get a displacement? Is it okay? Is it possible to get a displacement? Can we get? Because it is a fixed object, only rotate. Therefore, we can't get displacement. We can't, it is impossible. We can't get displacement. Think while rotating a fan like this type fan, while rotating the fan on the same point, right? On same axis. There is no any movement. Then don't have displacement. Therefore, in rotational motion, remember it is used angular displacement. Remember the new name. In rotational motion, we're not going to discuss displacement. It is changed as angular displacement. Angular displacement symbol, remember it is theta is the symbol. Theta, not D or S, it is theta. Theta is the symbol. What I told, in rotational and circular motion both, we can't get displacement because object not anywhere moving. Then we can't get a shortest distance. Instead of displacement, in linear motion, in rotational and circular motion, we can use a new quantity that we called as angular displacement. Angular displacement, it is a new quantity. Understood? Angular displacement. What's the meaning of angular displacement and every calculation? Today we discussed. Okay. Today we can discuss. I got. Up to now? Okay. Now, if we consider about velocity, is it possible to get velocity in rotational fan? Rotational fan or any circular motion object? No. Therefore, I am instead of velocity in rotational and circular motion, velocity, angular velocity, angular velocity, angular velocity. Remember, the symbol is, what is the symbol? What is this? This is a symbol. Is it W? No, W like this is W. Okay, remember this symbol we called as, after that, angular velocity. Angular velocity. Yes, very good. Omega. Omega is the angular velocity symbol. This is not the W. Understand the difference. This is a W. This is omega. This is a Greek letter. This is a Greek letter. This is omega. Omega. This is a W. Omega. Omega. The omega is the symbol, sign of the angular velocity. Angular velocity. If you go to acceleration, if we can't get velocity or displacement, it's impossible to get acceleration in rotational motion. Therefore, I can change that into a new form. It is angular acceleration. Angular acceleration. Angular acceleration. Angular acceleration. Remember the sign, symbol, it is alpha. Alpha. Not simple A, it is alpha. Okay. It is alpha. It is alpha. Okay. Instead of linear motion, in rotational and circular motion, we can use two physical quantities. We have two physical quantities in rotational and circular motion. The first one is a frequency. 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 Okay, one by one, again we can discuss. Now get familiar with this name. Okay, get familiar with this name. The frequency. The frequency symbol, simple F, not capital F, simple F. Simple F. Simple F. The final one, instead of time, we can use another physical quantity that we called as periodic time. Periodic time. Periodic time, it is capital T. Remember, the periodic time symbol is capital T. Frequency simple F. The time simple T. Symbols very important because in our calculations always we use these symbols in equations, expressions. Okay, they are the physical quantities we can use in rotational and circular motions. They are the linear motion. Okay, now our target, I'm going to start discuss one by one. What is the angular velocity? What is the angular displacement? What is the angular acceleration? What is the frequency? What is the perpendicular? Sorry, what is the periodic time? Then if we complete this part, the 60% of lesson is complete. Then we have very small part again. Okay, are you Understood up to now? I got the path we need to go in this lesson. Okay, now again practice. What are the names? Angular displacement. Angular displacement. What is the symbol? Theta. Angular velocity. What is the symbol? Omega. Angular acceleration. What is the symbol? Alpha. Frequency. What's the symbol? Simple F. Periodic time. What's the symbol? Capital T. Good. Yes. Okay, I have given already, no, in the tute. Yes, I have given. Sign means symbol. It is displacement S, velocity V, acceleration A, time T, angular displacement theta. This is omega. 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 Angular acceleration alpha. Alpha. Frequency simple F, periodic time capital T. Correct. Okay. Okay. Come to first subtopic. First subtopic, the angular displacement. Angular displacement. Okay, I'm not going to again discuss this linear motion. Now we come to lesson the angular displacement. Okay, this is our first subtopic, the first physical quantity that measure rotational and circular motion. Okay, the first physical quantity, it is rotational and circular motion. Sorry, the angular displacement. Angular displacement. Angular displacement, the symbol is theta. Now this is a problem actually. If you understood very well what's the meaning of the angular displacement, other all calculation, other all physical quantities, easily you can understand. Okay, now the problem is the displacement mean any distance, right? The shortest distance. The problem is in rotation any object, there is no any movement. There is no movement. Then how we get the displacement? That's the problem. What do you think? What do you think? Then how to get a displacement? How to get the displacement? Okay, think this is a rotational plate. Think this is a rotational plate. So this is a rotational axis. This is a rotational axis. This is the R radius of this plate. Radius of this plate. This point, think it is X point. This is the X point. Now think if it is rotate this point, if it is rotate up to this point, think up to this point. Again, X point එකම මෙතෙන්ට කරකෙන්නේ. හරිද? X point. Then this angle we called as the angular displacement. Understood? It is very simple. When any rotational or circular motion, the rotation angle we called as the angular displacement. Remember, it is very well in any circular or rotational motion, the rotation angle, the subtended rotation angle we called as the angular displacement. The other problem is, I told, to measure angles, we have two units. What are the units we used in previous lesson to measure angles? Angles measure karan, I told we can use two units. What are they? Yes, degrees and radian. But the thing is, the standard unit of this is angular displacement. The standard unit of this angular displacement, standard SI unit, not degree, it is radian. The standard unit of this angular displacement, it is radian. Now this is a problem. If you want, you can measure in degrees, no problem, but it is not the standard unit. It is like this. As example, for length of any substance, length we can use meters, we can use centimeters, we can use kilometers, we can use millimeters, or whatever unit. But what is the standard unit? Standard unit, meter. Okay, it is like this. We have two units, but the standard unit is radian. Press answer in radian. In the standard unit, you need to give it in radian. That's the rule. Okay, then simply the angular displacement is the rotational angle. The rotation angle. Okay. To understand that, think this rotation arc length is S now. The rotation arc length is okay. The rotation arc length is okay. Do you remember what's the definition of 1 radian? I told to revise again before today's lesson. What's the meaning of the 1 radian? I told 1 degree mean the angle of one circle divided into 360 equal parts. Then one part angle we called as 360 degree. Sorry, 1 degree. It is one part 360. 1 from 360. Okay, that we call as 1 degree. 1 degree. I think you can remember. Do you remember what's the of radian? 1 radian? Guys, before today class. Do you remember? Fatima? What's the definition of 1 radian? 1 rad? Anyone? Quickly. The arc length divided by the angle given by arc length equal to the radius. Very, very good, Mariam. Okay, that's a 1 degree. Very good, Mariam. The 1 radian mean the arc length equal the arc length given by angle equal to the radius. Do you remember? Think this one R and this yellow color arc length, it is equal to R. Think R equal 5 centimeter. If you got 5 centimeter arc length, it is given angle we called as 1 radian. Do you remember? Not. Then I will explain again. Do you remember? That's the meaning of 1 radian එකක් කියන්නේ the given angle arc length equal to the radius. Arc length equal to the radius. Do you remember? Radius එකට equal arc length එකකින් දෙන angle එක තමයි අපි කියන්නේ 1 radian එකක් කියන්නේ. Okay, then in the last lesson, in the radian lesson, I told the theta radian, the angle of any sector part in radian, we can get arc length divided by radius. Arc length divided by radius. As example, think this full sector part. The length of full sector part, it is 15 centimeter. Think it is 15 centimeter. It is 15 centimeter, right? 15 centimeter, the radius 5 centimeter. We can get theta radian, arc length 15 centimeter divided by radius 5 centimeter. Centimeter to centimeter cancel out. It is 3 rad. It is 3 rad. The 1 radian mean the arc length given by the angle given by arc length equal to the radius. The angle given by arc length equal to the radius. Then the theta radian we can calculate by arc length dividing by radius. Arc length dividing by radius. Clear up to now? Samya? Yes. Then any angular displacement, the angular displacement means theta. Okay, the angular displacement is theta. If you divide arc length by radius, then this is the theta radian. This is the angular displacement of any rotational or circular motion. So any rotational or circular motion, the angular displacement equal arc length divided by radius. Okay, arc length divided by radius. Arc length divided by radius. Okay, go to the tute. Go to the tute. Okay, the angle subtended by, this is the definition, the angle subtended by the rotational motion about the axis of rotation. The angle subtended by, mainly angle, if you remember the rotation, the angular displacement is the angle of rotation subtended to the axis, subtended to the axis. The unit of theta means the unit of angular displacement, it is radian, not degrees, the standard unit, the SI unit, the SI unit, the SI unit of the SI unit, the standard international unit. Okay, this is the arc length, this is arc length, and this is a radius and theta. It is given radius. Then the angular displacement theta equal arc length divided by radius, that you already know. Arc length equal by, then theta equal S over R, note down. Theta equal S over R, the standard unit, theta unit, rad. Theta unit radian. Okay, take a paper. Okay, take a paper, book. Paper, book. Anyway, write down question number one. Question number one. Question number one. A circular plate of radius 7 centimeter is rotating zero point 0.75 meter arc length. Calculate the angular displacement. Calculate the angular displacement of the plate. Calculate the angular displacement of the plate. Okay, quickly send me values. Okay, try to get answer within 1 minute, because this type answers always asking MCQ question. MCQ questions. For MCQ questions, you have very limited time. Good, Kabir. No, Dinul. Wrong. Dinul, wrong. Fatima, good. Vihanga, correct. Sanura, no units. Value correct, but you have mentioned the unit. Yes, Tumula, correct. Who, Kaude. Dinul, try again. Try to find the mistake. No, Maria. Wrong. You met? Good, Sadev. Okay, try again. You have mistakes. Yeah, now correctly. Okay. Yeah, I think you found your mistakes. Okay. What is the angular displacement? The angular displacement equal theta, right? The theta. The theta equal arc length divided by radius. Simple. Then the arc length is meter. Arc length is 0.57 meter. Radius 7 centimeter. It is in 2 units. Then if you substitute 7 centimeter and 0.75 meter, you can cancel out units. Yes, that's the problem. Then the arc length, you have two options. 7 you can convert into meter. Then you can cancel out meter to meter. If not, 0.75 convert into centimeter. 0.75 means 75 centimeter. 7 centimeter. Then centimeter, centimeter. Then it is cancelled. Then it is 10.71 rad. 10.71 rad. Remember, always to get in same unit. Same unit. It's a rule. Question number 2. Question number 2. Okay, write down a wind turbine. A wind turbine with 2 meter radius is rotating 10 revolutions in a particular time. Whatever time interval it is rotate 10 revolution. Calculates the angular displacement in this time. Calculate the angular displacement in this time. Okay, can you send me answer within 20 seconds? 30 seconds? Very good, Kabir. Yes, very simple. No need to calculate actually. Others? Fatima? Very good. You met? What is the answer with 5? Yeah, I think you're correct. No, Salmia, no. You're correct. Okay, then correct. No, Maria. Wrong. No, Sandeep. Yeah, you got the point, but wrong. Good. Mul. Yeah, you met. What's the answer? Yes. Now actually don't need to calculate it. That's why I told before lesson go through again radian and degree relationships. Yeah, right. Uh, think this is a 10 revolutions. No, 10 revolutions. 10 revolutions. If it is one revolution, what is the degree? What is the angle? It is 360. No, it is 360. I told 360 degree equal 360 degree equal 360 degree equal I told what is the no, I will show you. Now it is if you got one full revolution, the arc length is the circumference. Right? The arc length is a circumference. The one full revolution, the theta length circumference is 2 pi r divided by radius. Then r to r cancel. The theta mean 360 degree equal 2 pi rad that I already explained in the area volume lesson in the basic mathematics. 360 degree equal to 5 radian. That's why I told it is basic mathematics lessons, not important for area and volume and Pythagoras theorem trigonometry. It is important for other all physics and chemistry lessons. Okay, then the 360 degree equal to 5 radian. 2 pi radian, 360 degree mean one revolution. It is equal to 2 pi radian. Then the question given, it is 10 revolutions, then it is answer per one revolution 2 pi rad, 10 revolutions 2 pi into 10, it is 25 rad. Mariam understood? Samya? Yes. Then if you know the number of revolution, always when rotate full revolution, remember the angular displacement 2 pi radian. The angular displacement mean this angle, right? Theta. This angle is angular displacement, mean rotating angle simply. Then one full revolution rotating angle in radian, it is 2 phi. Therefore, in one full revolution, the angular displacement 2 phi rad. One full revolution angular displacement 2 phi rad. If you got 10 revolution, it is 25 rad. 5, not 5, 25 rad. If you got 40 revolutions, it is 85 rad. If you got 2 revolutions, it is 4, 5 rad. Yes, always the number of revolution multiply with 2, 5. Then it is coming the displacement, angular displacement within these revolutions. Understood? Yes. Okay. Okay, come to our topic number 2, angular velocity. Angular velocity. Angular velocity. Angular velocity. Angular velocity, what's the symbol? It is omega. Omega. Angular velocity, it is omega. Okay, do you remember what's the meaning of the velocity? The rate of displacement change. Eka matakai nang. Then angular velocity is simple. The rate of angular displacement change. Okay, the rate of angular displacement change we called as the angular displacement change. Angular displacement change we called as the angular velocity. It is very simple. Then angular velocity equal omega equal angular displacement, it is theta divided by time. The angular displacement change within unit time. It is same as velocity. මේ වචන දෙකක් angular එන එක විතරයි actually the difference. Angular velocity, it is same as velocity. The angular displacement change within unit time. The angular displacement change within unit time. Okay, now what is the unit of velocity? What do you think? What's the unit? Standard unit of angular velocity? Omega. What's the unit? What's the unit of angular velocity? Very good. It is theta unit is radian divided by second. Then radians ts minus 1 is the unit of angular displacement. So the angular velocity. The angular displacement unit radian. The radians per second. In velocity unit is meters per second. Do you remember? ms minus 1. It is velocity unit. But the angular velocity unit radians per second. Rad s minus 1. R radius minus 1. R radius minus 1. Okay, it is very simple. The angular displacement change within unit time or the rate of angular displacement change. Remember these definitions. That's why if you remember all these definitions and if you understood all these concepts very well, that's why I told without any equation you can do this calculation if you got very well. The angular displacement within unit time or the rate of angular displacement change, the omega equal angular displacement theta divided by time t. Okay, let's move into tut. The rate of change of angular displacement is called as angular velocity. The unit of omega is radians per second. Radians per second. The angular velocity equal angular displacement difference divided by time. Then you can get relationship. Then the unit is unit rad is minus 1. Remember. radians per second. 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 Okay. Take the paper again. Paper number. Question number 1. Question number 1. Question number 1. A circular plate rotates. Sorry. A circular plate with 10 centimeter radius rotates 0.98 meter arc length within a 1 minute. Within a 1 minute. Within a 1 minute. Calculate the angular velocity. Velocity of the plate. Calculate the angular velocity of the plate. Okay, take only 1 minute. Kabir. Mariam, it is asking the angular velocity. Angular velocity. Yes, it is very small values. Say very small value. Yes, all are correct. Yes. Good. Correct. Yes, angular velocity. You have to divide by time. Yes, correct. Yes, Ishan, correct. Okay, good. Okay, now what's the method? First of all, you need to find the theta. The theta mean angular displacement. Angular displacement S over R, S over R, uh, S over R, the S 98 centimeter or 9.0.98 meter divided by 0.1 meter, then it is divided by 10 centimeter. It is easy. Okay, 98 divided by 10, it is 9.8 radian is the theta. Theta 9.8, it is correct. But you need to get the omega. Omega equal theta divided by time. Now, uh, what is the time? 9.8 divided by time within 1 minute. You can substitute 1, you need to substitute in standard unit always. It is a standard unit. Then the 1 minute mean how many seconds? 60 seconds. 60 seconds. It is rats. Then it is coming 0.16 rad per second. R rad S minus 1. Complete? Yes. Mariam, understood? Okay. Now, next question. Question number 2. Five hundred revolutions within 1 hour. Calculate the angular velocity within this time. Okay, a merry-go-round is rotating 500 revolutions within 1 hour. Calculate the angular velocity within this time. Okay, quickly get this. Calculate the angular velocity within this time. Yeah. Yeah, different answers. Why? Within 1 hour, 1 hour. Okay. Sanuga, what's the value? Hmm. Hmm. Different answers. Okay, let's see. I think it is 0 point value, right? It's a very small value because within 1 hour, 500 revolutions. 500 revolutions. Okay, let's try. Okay, first of all, you need to find theta. Theta, no need to calculate. It is 500 revolutions. No? Within 500 revolutions, how many theta? How many angular displacement? It is 500 into 2, 5. It is 1005. 1005 radian. 1005 radian. Now, omega equals theta over time. The theta 1005 rad divide by 1 hour mean how many seconds? 60 into 60. 3600. 60 into 60 because per 1 minute 60 seconds, per 1 hour how many minutes? 60. 60 into 6, 3600 seconds. 3600 seconds. Now it is 3600 seconds. Now 2020 cancel out. 2020 cancel out. Then answer. What's the answer? Uh, 100 divided by, sorry, 10 divided by 36. What's the answer? 10 divided by 30. 100, it is 3. 2. Yeah, 27, right? 0.27 radian or 0.275 similar. 0.275 radians per second. Harith. Wait, I will check with calculate. Yes, 0.275 rad. If you want to get decimal value, you have to multiply with this 0.27 into 5 value. I got, then how you got different answers? Yes, Kabir, correct. Tumula, not 0.27 only, 0.275. Fatima, it is 0.87 when multiplied with 5, right? 3.14 multiply with 3.14. Yeah, 0.872. Yeah, decimal point is 0.872 rad per second. Okay, then both answer correct. Any answer acceptable. 0.87. Then who got? Yes, Tinul correct. Sarmia, are you understood? Yes, Vihenga correct. Okay, now correct. Okay, any doubt, please ask if you have. So, can we keep the final value without multiplying by 5? Or do we have to get the decimal value in the exam? In the exam, you can get the value. Lot of this type questions asked in MCQ questions. No any essay questions, very rare. In our past papers, only one essay questions asking from this lesson. Always at least 3 MCQ questions asked. 3 MCQ important, 3 marks. Then MCQ questions, it is depend on the answers. MCQ questions, if they give an answer in terms of 5, then you need to provide answer in terms of 5. If they given decimal values, you need to convert into decimal. In essay part, it's better to note down both. මේක අරගෙනනේ කොහොමත් මේක ගන්න වෙන්නේ. Then essay part, it is safe to 0.275 radians per second. If you write again 0.872 in the calculator, you can just get the value. You can note down both in essay part. In MCQ, it's not problem. Okay, Vihen? Okay, let's do this. Is doing today because our old physical classes is stopping here. Okay, we have more 12 minutes. Okay, let's try to get the okay, you know how many times it will take by the earth to rotate around sun. Think this is the sun. Yeah, it's a fun work. This is a sun, earth. How many times rotate around sun? කොච්චර time යනවද? Approximate. How many times? Yeah, 365 days. Very good. For this one rotation, earth one rotation, it is take 365 days. That means within 1 year. අවුරුද්දක් ගන්න. It takes 1 year. Okay. For one revolution, the earth takes 365 days. 365 days. Okay, let's try to get the angular velocity of the Earth. It's a circular motion. The rotation and circular motion, same method. The angular velocity mean the angle change within unit time, the angular displacement change within unit time. Okay, let's try to get the per one revolution, it is rotate 365 days. Okay, let's try to get this. Okay, write down a question. The Earth rotates, the Earth rotates, question number 3, rotates one revolution around sun. Around sun within 365 days. Calculate the omega of the Earth. Calculate the angular velocity of the Earth. Calculate the angular velocity of the Earth. Okay, let's try to get this. Let's try. I need to get the angular velocity of the sun. Omega. It takes 365 days per one revolution. It is a very, very small value. Try to get. Okay, what's the method? Okay, I'm going to get. That's a fun work. It is a very small value. Actually, we rotate around the sun in this angular velocity. Okay, the angular velocity omega equal theta over time. The theta is one revolution. එක revolution එකයි. Then it is 2 phi rad. 2 phi radian is the angular displacement. Divide by time 365 days. But for get standard unit 365 days, I need to convert into 365 days. 365 days. How many hours? 25 hours. 25 hours per day. Then how many seconds for 1 hour? How many seconds per 1 hour? It is 3600. This is the, if you got this value, this is the angular velocity of the Earth around sun. අපි sun එක වටේ යන this much of very small angular velocity. That's why we can't feel this. Actually, now also we rotating, but we can't feel it. Yeah, this much of 31,000 seconds, right? How does a leap year made? Do we add 6 hours from 4 years to make a single days? Yeah. No, I'm asking in the normal year. Normal year. If you want, you can add these additional 4 hours, right? Yeah, it is very, very small value, right? Then 2 divided by, you can use calculator. it is 0.00000 1 2 3 4 5 6 0.000000199, right? 99 radians per seconds. Per 1 second, this much of very small value, it is rotating. I got understood. A very small value. It's a very small value. That's why we can't feel it is rotating. It is very small value. It is rotating. It's take 365 days per one revolution. Yes. Okay, if you want, you can try the Earth rotation. Per one rotation, how about time is taking? Earth, one rotation mean like this. May rotation naked. Per one rotation, how many time it will take? Bianca, what is per one rotation? Yes, it is 24 hours. 24 hours. Yes, you met. Yeah, it is 24 hours. May wage rotate per one rotation. One rotation around itself. On rotation, it's take 1 day. 1 day mean 24 hours. 24 hours. Then you can, if you want, you can calculate this one also, because omega per one revolution, omega equal one revolution mean 25 rad. 25 rad divided by 25 in 24 into 3600. 3600. Okay, this value is the rotation angular velocity. The Earth rotation angular velocity. Earth circulation angular velocity we got, it is very small value. That one also very small value. Yes. Yeah. It is a okay. I got this type. Any rotation, now we can calculate angular displacement and angular velocity. Now you have all basic knowledge of rotational and circular motion. Then we can discuss next week our second part of rotational and circular motion. In next week we can complete 60% of the lesson, as I told. Yeah, this is yeah. Today I told angular displacement and angular velocity completed. In next week, angular acceleration, frequency, and periodic time, we can calculations. Then 50 to 55% is completed. Then within this month, actually, we can complete this lesson. It's a very small but little bit complex lesson. Therefore, don't miss any part. If you continuous attending, and if you work, try to understand this concept very well. It's simple actually. It is very simple. Without any equation, you can do all calculations. But if you miss any part, again, when you try to understand it, it will be very difficult. Okay, that's an all lessons after that in our syllabus. If you continuous working, it is very simple. If you miss any part, it will be very difficult in this lesson. Okay, that's the today lesson. Next week we can discuss the remaining part of the lesson. Okay, any doubt? And remember that this is your exam This is your exam. 25th of Saturday morning. 25th of Saturday morning. Okay. Okay. If you don't have doubt, we can stop for today. The other thing, again, go to next week. Then otherwise, it will be difficult. If you know as a sequence, if you know everything, it will be very easy. Okay, then good night. Have a nice day.